Hello students, good morning. In this session we will start a new topic, that is chapter 4, carbon and its compounds. So in nature there are so many elements. We have around 118 elements. So all of these elements we have selected carbon. So why we have to study about the carbon? Because this carbon is the most important element and it is a versatile element. Hence we will study about the carbon and its compounds. So where do you see this carbon? So carbon occurs everywhere. It is present in the atmosphere, in the earth's crust, and also all the living organisms, they are carbon based. And this carbon, it is also present in the fossil fuels like coal and petroleum, and also in the form of compounds, carbonates, hydrogen carbonates, and also in the food, medicines, clothes, books. The paper is made up of carbon. So we can see the things which are made up of carbon. In the earth's crust, around 0.02% of the carbon is present in the form of the minerals. And in the atmosphere, it is present as the carbon dioxide. Around 0.03% is present. So in spite of this small amount available in the nature, so the importance of the carbon is very immense. So we will study the properties of this carbon in this chapter. So this carbon, the symbol is C. And if you see, the atomic number is 6 and the atomic weight is 12. The electronic configuration is 2, 4. Okay, and if you see the physical state at 20 degrees Celsius, it is in the solid form and the structure is hexagonal. Okay, so then what are the properties of this carbon? So the first property is catenation. So this catenation means it is the self-linking properties. Okay, so this carbon has the unique ability to form the bond with the other atoms of the carbon to form a large molecules. This property is called as catenation. So these compounds, they may form the long chains of carbon. Okay, or they can form a branched chains of carbon, or the carbon atoms arranged in a rings. So you can see in the figure there are straight chains. They can form the long chains, or they can be branched. They can be also branched. The carbon can be arranged in the branched form or in a ring form. Okay, so this property is called as catenation. So no other element will exhibit this property of the catenation like how the carbon will form. This silicon, one more element is there, silicon. It can also form the catenation, but only up to 7 or 8 atoms can be formed. But they are highly reactive. This carbon-carbon bond, what is formed, is very strong. So this gives the large number of compounds with many carbon atoms linked to each other. Hence this carbon is a special element. Okay, and next property is tetravalency. Here what is valency? Valency means it is the combining capacity of the atom. This carbon, it has a valency of 4. Okay, that is, it is capable of bonding with the 4 other atoms of the carbon or atoms of some other element. Okay, some other element may be oxygen, hydrogen, or nitrogen or sulfur, chlorine, and many other elements can bond with the carbon. So how this carbon will bond? This carbon, I told there is a 4 electrons in the outermost shell. So by sharing the electrons, this carbon will bond with the other atoms. So how the bond is formed, we will study this little later. Okay, so this tetravalency means the carbon has 4 electrons. So this carbon can bond with the 4 different elements or with the 4 carbon atoms. Clear? So next is multiple bonding. So this carbon, it will show the multiple bonding property. That means it can form a single bond or a double bond or a triple bond. Okay. So with the single bond, it can attach to 4 different elements, or with a double bond or a triple bond. So this is the multiple bonding of the carbon. So due to these special properties, that is catenation, tetravalency and multiple bonding, this carbon is versatile in nature. That is, it forms so many compounds that will create a new branch to study it. So that branch name is organic chemistry. So organic chemistry means the branch which deals with the carbon and its compounds. So these compounds, they cannot be created artificially. But the very first organic compound which was man-made was urea. So this urea is an organic compound which was created by the man. That is by the name scientist Frederick Euler. Actually, he was doing some other experiment. By chance, he identified this urea. And the most common organic compound is hydrocarbons. Hydrocarbons means the compounds which are made by carbon and hydrogen and traces of some other elements. Okay, so in this figure you can see the center is carbon, and here H, it is bonded with the 4 different H. So this forms CH4, that is methane. Methane is a gas. So these are the hydrocarbons. Next is bonding in carbon. That is, it forms the covalent bond. Covalent bond means it is a chemical bond that involves the sharing of electrons pairs between the atoms. Okay, so in the previous chapter we have studied about the ionic compounds. So how ionic compounds are formed and what are the properties of ionic compounds. So you know that they have high melting point and high boiling point, and they are also good conductors of electricity in the molten state. So the nature of the ionic bond will explain the properties of the ionic compounds. So now we will study some of the carbon compounds, that is acetic acid. So the melting point of acetic acid is 290 Kelvin and boiling point is 391 Kelvin. Chloroform, so the 209 Kelvin is the melting point and 334 Kelvin is the boiling point. Ethanol, it has 156 Kelvin melting point and 351 Kelvin boiling point. And methane, melting point is 90 Kelvin and boiling point is 111 Kelvin. So by this data, what you can conclude is the force of attraction between these molecules, they are not very strong. Okay. Next, you also have learned about the valency. So what is valency? The combining capacity of the various elements, that is called as valency. And it depends upon the valence electrons. So if you previously I have told you what is the electronic configuration of the carbon. So the atomic number is 6 and the electronic configuration is 2, 4. So the outermost shell has 4 electrons. So the valence electron is 4. Okay. So the reactivity, how the reactivity depends. It depends upon the tendency to attain the completely filled outer shell. That is, it will attain the noble gas configuration. Okay. So the elements forming the ionic compounds, they achieve by gaining or losing the electrons from the outermost shell in case of ionic compounds. But in case of carbon, it has 4 electrons. Okay, that is 4 valence electrons, and it needs to gain 4 electrons or it can lose 4 electrons to attain the noble gas configuration. Okay, suppose if it has to gain the 4 electrons, suppose if the carbon gains 4 electrons, it will form anion. This is the anion. Okay, but it is very difficult for the nucleus. So the carbon nucleus has 6 protons. So this nucleus, it cannot hold the total 10 electrons. Okay, in the nucleus 6 protons are there, plus if it gains 4 electrons, so totally 10 electrons it cannot hold. Okay, suppose if it lose 4 electrons, that is, it forms the cation. Okay, but it requires a large amount of energy to remove the 4 electrons. So to lose 4 electrons, it requires more amount of energy. Okay, so this is also difficult for the carbon. So to overcome this problem, this carbon, it will share the electrons with the other atoms of carbon or with the atoms of the other elements. Okay, the carbon will not lose or will not gain electron, but instead it will share the valence electrons with the carbon or with the other atoms of the other elements. Okay, so the shared electrons, they belong to the outer shells of both the atoms. Okay, so this will attain the noble gas configuration. So both the atoms will attain the noble gas configuration. Okay, so other than the carbon, there are other elements also which forms the covalent bond. So we will study which are those other elements which forms the bond by sharing the electrons. So examples, the first one is hydrogen. Okay, so that atomic number of hydrogen is 1. So to attain the stability, it requires one more electron. So in the K shell, one electron is present. It requires one more electron to fill that K shell. So it will share with the other hydrogen atom to form the molecule of hydrogen. So how you depict this by electron dot structure? So here H, hydrogen, it has one electron. Okay, and one more hydrogen has one electron. So it will share. So 2 electrons. It will form a single bond. Hydrogen, hydrogen, single bond is formed, because only 2 electrons are shared here, hence it will form a single bond. Okay. So you take one more example, that is oxygen. O2. So you know the electronic configuration is 2, 6. So it requires 2 electrons to become the octet. So oxygen has 6 electrons in the outer shell, and one more oxygen has 6 electrons. Okay. So these two are shared. So these 2 electrons will be shared. I am showing like this. Okay. So this is how the electrons are shared between the 2 oxygen atoms. Here totally 4 electrons are shared. Hence it will form the oxygen-oxygen double bond. Clear? Next, one more example is nitrogen. Okay. So here the electronic configuration is 2, 5. So it requires 3 more electrons to become the octet. So one nitrogen has totally 5 electrons in the outermost orbit. 1, 2, 3, 4, 5. And one more nitrogen also has totally 5 electrons. Okay. So it will share 3 electrons. So totally 3 bonds are formed between the nitrogen. It is triple bond. Clear? So this is how the electrons are shared between the hydrogen, oxygen and nitrogen. So we'll see one more example, that is the carbon tetrachloride and methane. Okay. So here carbon has 4 electrons, and hydrogen has 1 electron. So the 1 electron from hydrogen is shared here, 1 electron of hydrogen and 1 electron of carbon. So the structure is like this. And in case of carbon tetrachloride, so here also carbon has 4 valence electron and chlorine also has 1 electron. It requires 1 more electron, so it will share with the carbon and forms the carbon tetrachloride. Clear? Okay, we'll stop here. We'll continue in the next session. Thank you.